Hi, geometry students, and here we are at the end of April, our last week in April, and I hope this finds you doing well, and I hope the weather's nice. But today we are actually going to be reviewing a little bit of 9.2. If you recall, at the end of our last class, we had run out of time for me to try and explain the triangular example, and then I also want to briefly mention the cylinder formula for finding the surface area. So this is technically a little bit of the end of 9.2, and then we'll be covering 9.3. So I'd like for you to actually take a look at page it's the lesson that begins on page 483. So we are going to be taking a look at the example that I was doing when there was a little bit of a disagreement about the base area or the base configuration. So I want to explain that further. We had run out of time, so I really couldn't do that. So I want you to take a look at page 484. And it's example number 2, and this was the triangle that we were looking at, and I had asked you to notice what the base was, and the base appears to be a rectangular base. Now, one of the things that we didn't get to look at was a little thing, and I assume that you have this in your book. It says visualize it. Now, that's as far as we got, was the disagreement about whether this was a rectangular base or a triangular base. Now, if we had been able to go further, I would have pointed this out to you. It says it may help you to visualize the bases and the height if you redraw the solid in example 2 so that it lies on its base. As it was, the base appeared to be rectangular. But one of the things that makes it extremely helpful with triangles is actually to lay it on its base, because that rectangular piece is deceiving and it looks rectangular and it can be very confusing. But if you lay it on its side, which would have been the next step in my presentation at school, if you lay it on its side, then it truly does look like the triangular prism and not something with a rectangular base. So hopefully that clears up the confusion as we began to do this example the other day. So let's take a look at that sample problem. It was example number 2. And here is the triangle as it appears in the book, with what seems to be a rectangular base. Here, however, is the triangle laid on its side with the true triangular base. Now we can actually proceed in figuring out that surface area, or the base, the measurement of the base. So in order to find the base, now that we know we're dealing with a triangle here, is 1/2 and then times 4 this side and 3. Ignore 2 for a moment. So that comes out 1/2 of 4 is 2 times the 3 is 6. So there we have our triangular base. Now we want to find the perimeter of the base. And so we know that we have 3. Let's pretend we have a triangular room we're going to get carpet or get paint for. 3 plus 4, and then here's the other side, 5. They've just put this up at the top because they know that we can't see it down there. So 3 plus 4 plus 5 comes out to be 12. Then it says to find the height of the prism, and the height is this. So what's standing up and down right there? So it really is helpful if you lay this prism on its triangular base, not allow it to stay on the rectangular piece. So then we're going to use our formula to find the surface area for this prism. And that formula, surface area equals 2 times base plus the perimeter times height. It's just algebra. We now just stick in values for those, not for those letters. So 2 times 6, we had determined up here the area, the base. So 2 times the base is 2 times 6. Then the perimeter we had determined was 12, and the height we already knew was 2. So we will have 2 times 6 is 12 plus 24, or 36. The surface area of the prism is 36 square meters. So I hope that explanation was helpful. I would also like for you to take a look at page 485, where it gives the formula for a cylinder, and we're actually going to be using that in a future lesson. So make sure you take a look at that formula. So the surface area is going to equal 2 times the base, the area of the base, plus the circumference of the base times the height. So please take a look at page 485, and hopefully in your homework you were able to do some examples from the cylinders, but we will be discussing that a little bit more in these next lessons. So now let's go ahead and take a look at 9.3, and this is going to be the surface area of pyramids. And so if you look on page 491, you will actually see a picture of a pyramid, but then 2 diagrams explaining some things and actually giving you some definitions, which we do need to keep in mind. So the height of a pyramid is the perpendicular distance. If you start at the top, that's the vertex that drops straight down. So imagine being an early pyramid builder, and you might have wanted to put a column straight from the top down to hold the pyramid in place. My kids made an igloo a while back during one of our blizzards years ago, and one of their problems was that they didn't have something to hold it up there at that top. Now theirs was a circular igloo, but if you were an early pyramid builder, this might have been a concern. Remember, they were quite smart, and I don't know that they needed columns that went straight from the top down. But this is just a straight up and down line, and this is the height. The vertex is this here at the very top, and the base is what we would sit on. That would be the floor that we would sit on. Now, there's another height that we need to take into consideration, and that's the slant height. That is what kind of goes, and if you follow my mouse, it's going to kind of go at an angle. In another world, in algebra, we kind of called that the slope, but don't confuse them. I'm just trying to give you an idea. It's not straight up and down. It is slanted, thus the word slant height. That is represented by this little cursive L, and it's just what starts at the base and it slants upward. And so we're going to be talking about both of those today. So I want you to take a look at example number 1, and they want to teach us how to find the slant height. So it says, find the slant height of the rainforest pyramid. Round your answer to the nearest whole number. Then our explanation here: to find the slant height, use the right triangle formed by the height and half of the base. That's what's right here. We want to find that. And so slant height squared, we're going to have everything squared. So make sure you remember we've worked a little bit with exponents. So we want to be using those. So everything's squared. Slant height is squared, height is squared, and then 1/2 of the side, we're going to square that. So all we're going to do is plug in the numbers. So we know that the height, this is the height. We want to find the slant height. We want to find this right here. We know that the straight up and down height is 100 feet. So we're going to put that in, 100 squared plus, and then we look down here at our side. That's 200. We're going to take half of that. 1/2 of 200 is going to be 100. So we have 100 squared and 100 squared, which is 10,000 plus 10,000. Now remember, up here we have slant height is squared. So remember back in the day when we dealt with squares and exponents, to get rid of that squared, you have to put it in a little square root sign. So we would have slant height in the square root, 20,000 in the square root sign, and then you would have to do the math using a calculator. It points it out, and it's going to come to about 141 feet. So that is how you find the slant height. That's the example for this one. So all of these different formulas that I'm giving you should be put on an index card. Otherwise, you're going to get these formulas confused. So even going back to 9.1 and 9.2, make an index card with each formula on it so that you don't forget what you're squaring and what you're putting in the radical and how to get it out. Make sure that you have an example there. All right, now we want to determine the surface area of a pyramid. And so this diagram here is showing if we broke it apart. So if I came into school with a pyramid and then I broke it apart, it would appear to look something like this. And so it shows you how we would find the base, which is this green part right here, and then how we would find the area of the lateral faces, the parts that build the walls. So the blue parts are what builds the walls. So it's just showing you how you break that down. And that is on page 492. So if you want to pause the video, take a look at that a little bit to make sure you understand it. So then we have another formula. So every time you see, not a formula, formula. Every time you see a formula, every time you see a definition, these should be part of your index cards. We are probably going to take an exam in class, and so it will be important that you have those index cards and that you don't trust on your resources at home. So to find the surface area of a pyramid, S is always going to stand for surface area. So S equals base, the area of the base, plus 1/2 of the perimeter of the base times the slant height. So that's why we needed to find the slant height back here. If you don't have the slant height, then you can't find your surface area. So let's go back there. So now let's do an example with that. So it find the surface area of a pyramid, find the surface area, and you're going to need to have a couple of steps. So if you remember back in our algebra days, sometimes we had multiple steps. So I'm going to go through this example, and then I'm going to do one of the checkpoints so that hopefully you understand it. So it wants us to first find the area of the base. So here's the base, 6, 6. So we note that to find the area, we're just going to multiply those together. So we come up with 36. There is that answer. This example is on page 492 if you would rather follow along there. Now we want to do the perimeter, and we know that it's 6 plus 6 plus 6 plus 6. And that's coming to 24. Now we have to find the slant height, and we know that formula, slant height squared equals height squared plus 1/2 the side squared. So we are going to come here and find out that our height is 4 feet, the one that goes straight up and down. The column that I think needs to be put in place to hold up the pyramid straight up and down is going to be 4 squared. Then 1/2 the side is going to be 3, and that's going to be squared. So we're going to have 16 plus 9, which comes to 25. But remember, I've got to put the radical here over slant height. I put the radical here over 25, and I am able to determine then that the slant height is 5. Now I can go through and do the other part of this formula to find the surface area. So multiple steps. Don't forget, you got to find the slant height first. So we're going to substitute everything in. S equals, and then the base we already determined is 36, so there is that. And then 1/2 P times L is going to be 24. And so I put everything in. The P and the L is 24 and 5. I do all my multiplication. I add everything up and I come to 96. So my surface area is 96. My slant height is 5. And chances are on an exam I will have you label the slant height so that then you can go on and find the surface area. Okay, let's do an example. This one is checkpoint number 3. Let me just tell you, if you do number 1 and number 2, they are decimal answers. So if you try those, see what you come up with. All right, we're going to take it by steps. So figure out the base. That's going to be 10 times 10. That will equal 100. Now if you want to do this on your own and then come back and follow me through it, just pause and come back when you want. Next we have to figure out the perimeter. It's going to be 10 plus 10 plus 10 plus 10. And that's going to be, I should have written it in here, is 40. Alrighty. Now we need to find the slant height. That's kind of the slope of this wall. And in order to do that, it's going to be slant height squared equals height squared plus 1/2 a side squared. So I've taken it through all the steps. Slant height squared equals 12. Here's the perpendicular, the regular height, 12 times 12. And then 1/2 of the sides is 5, so 5 times 5 equals 25. So 144 plus 25 is going to come to 169. Then I put my slant height words in the radical and my 169 in the radical, and I'm left with slant height equals 13. So now I could label that if I wanted to. L equals 13. I go back to my original formula to find the surface area. Surface area is going to equal base plus 1/2 perimeter times L, which is the slant height. So my base was 100. I found that earlier. And then 1/2 of my perimeter is going to be 40. The perimeter's 40, and then times 13. So when I do all the multiplication, it will be 1/2 times, or it will be 1/2 times 40, which is 20, times 13. And then you add the 100 and you come up with 360. So I've taken you step by step on this. So use this slide if you need help doing your homework later. All right, I know this is a long one, but we're going to look at cones quickly, and we need to also find the surface area of cones. It's a little easier. So surface area is base plus pi times radius times the slant height. Here we've got a slant height again. So we want to be able to do the multiplication on our little formula here and figure out what the surface area is going to be. So let's do an example. That's always the best way. It says find the surface area of a cone to the nearest whole number. Again, you could come up with decimals. So the radius of the base is 4 inches. So remember I told you about your cylinders. We need to make sure that we understand the circle, cylinder, and cone formulas because we're working with pi and we're working with the radius. So if we're just looking at the circle here, that's what I'm shading here. Pi r squared plus pi r times the slant height. So we're going to write the formula. Should be on your index cards. Should be on your paper if you think you're going to get confused. So pi times, here's the 4 radius squared, plus pi again, 3.14, I don't know why I went up there, and then times the radius again, plus the slant height, which they've told us is 6. You didn't have to find it. They told us it was 6. So we do a 4 times 4, which is 16, times the 3.14. And then 3.14 times 4 times 6. And you end up with 40 times pi, or 126. So this one's not as hard because you just have your formula there. If you have to find the slant height, let me see if that's my next slide. Slant height. Yes, here's my next slide. In order to find the slant height, it's going to be slant height squared equals the radius squared plus the regular height squared. So if we look back at this, the radius is 4. Then the regular height, actually they're doing it in this one. Sorry, I'm gonna jump ship and do this one. The radius is 12 in this one, and it is the height, straight up and down, is 5 feet. So now let's go back. That will make some sense. So 12, that was the radius. 12 squared is 144. The straight up and down height was 5, so 5 times 5. And then when you add all that together, you get 169. But remember, you have to put slant height in the radical, 169 in the radical, and then your slant height is 13. So if you need to find the slant height, that's the second piece of information that you will need. And then you go back and you substitute everything into that original formula right up here. Make sure it's on your index card, and you will be able to find the area of the cone, which in this case for the bigger cone is 942. Or 942 square feet if they give us the, I call it the address, but the measurements. So here we have square inches, here we have square feet. Okay. So here is an example of finding the surface area. Hopefully they give you the slant height. Maybe not. And if they don't, they would have given you the height, and you will figure it out from there. But here's an example. So here's our formula. Pi r squared plus pi times the radius times the slant height. Remember the little L, the italicized L represents slant height. So we'll plug everything in. So here my radius is 10. 10 times 10 is 100. 3.14 times 100 plus 3.14 times 10 times 12. And your area is going to come up to 690. So hopefully you have all these formulas written down and you know when to use them. I would definitely pull out some examples from the book and write them on your index card. Again, so that you can remember when to use each sample. So hopefully that has cleared up 9.2 and 9.3. If you have homework questions as you do these, I want you to make sure that you ask them in class, because I'm going to try to do a period of review on the first 4 lessons in 9, and so that we can clear up for everybody if there's any confusion. So let me know if you have questions, and I will see you tomorrow for lesson 9.3.